Sodium dithionite is a useful reducing agent in organic synthesis, but unfortunately we can't get hold of it where we are. So we thought we'd have a go at making it using sodium bisulfite. We've tried a few times now, so this process is the result of a little bit of tweaking, but you could probably improve it further. We're starting off with 50 grams of sodium bisulfite, which is a fine white powder, as you can see here. We've weighed this into a 250 ml beaker, and now let's get a large magnetic stir bar in there. We're going to use 50 ml of water. You can use more if you want, but you won't get as concentrated a solution at the end, and making a solid product will be more difficult. So we add this to the beaker. Now we've set up the beaker on a magnetic stirrer and with a thermometer inserted into the liquid so we can monitor the temperature. The beaker is also sitting in a bowl, which is empty to begin with. Just before you're ready to do the reaction, place some ice in the bowl. This will cool the mixture a little, but when we're ready for more cooling we'll add water to this. You can see that some of the sodium bisulfite doesn't dissolve in the water, but this is okay. Now for our reducing agent. We're going to be using zinc powder. We noticed that this has a tendency to clump up and form lumps like this during storage. So we took the lumps and sandwiched them between two pieces of paper and then used a glass bottle to roll them out until we had a very fine gray powder. Here at Island we've got 19 grams of our fine zinc powder here. This is a slight excess to what we need. Okay, back to our sodium bisulfite. The mixture is starting at around 20 degrees C. Note that the reaction needs some heat to get started. If you try to do this at a lower temperature, there's a risk that it won't work. So with stirring on quite vigorously, we'll add the zinc to the sodium bisulfite mixture. And at the same time we add the water to the ice bath, making sure that the mixture is strongly cool. The temperature of the mixture increases as the reaction takes place. And you'll see the consistency of the mixture becoming more viscous and changing to a gray color. Soon stirring becomes quite difficult as solid zinc hydroxide precipitates into the mixture. The maximum temperature was about 45 degrees C, after which the temperature drops again and the mixture cools back down quite rapidly. As you can see, the resulting mixture is quite a thick paste, and a lighter gray due to the white zinc hydroxide which has formed. There's still a little unreacted excess zinc present as well. So next we measured out 10 ml of water. Add this to the mixture and stir well, breaking up any lumps. This will form a thick but still liquid mixture. Here we are. A nice homogeneous mixture. So now we filter the mixture while it's still slightly warm. Unfortunately, filtration is quite slow, as you can see, even using a vacuum pump. When a semi-solid remains in the pump, don't allow too much air to be drawn through it because our product is air sensitive and can easily be oxidized. We'll wash the precipitate in the filtered funnel twice, each time using 10 ml of warm water. Rinse out the reaction beaker. And then mix the washing water well with the precipitate so that as much product as possible is dissolved and extracted. Then filter again and repeat the process. On the final run, leave the filter running in order to get as much liquid as possible out of the solid in the filter. In the end we collected about 60 ml in total of filtrate. This is our solution of sodium dithionite. It does contain a small amount of sodium bisulfite, and also some decomposition products such as thiosulfate. But this works well as a reducing solution, so we recommend using this directly as it is. You can prepare a solid product by dehydrating the solution using absolute ethanol. Here we've got about 15 ml of the filtrate on the left, and about 75 ml of absolute ethanol on the right. As we pour the filtrate into the ethanol, you can see a cloudiness appearing. Since sodium dithionite is slightly soluble in ethanol, we'll chill this mixture down to 0 degrees C in a freezer now. Here's the result. You can see a solid has separated and settled on the bottom of the beaker. So we set up for filtration once again. We've put a thermometer into the filter funnel. Our solid product is going to be slightly damp and as a result will be rapidly oxidized by air passing through the pump. This reaction is strongly exothermic. Once the liquid is filtered off, the temperature starts to rise. Here's our product. This is approximately 8 grams of sodium dithionite, which we believe is the dihydrate crystalline salt. Given we used a quarter of the filtrate, this means a potential 32 grams of product in total, which would correspond to an approximately 63% yield. It does seem, however, that the solid product obtained in this way is not stable though. If we leave the thermometer sitting in the pile of powder, after just a few minutes the temperature has risen quite dramatically and keeps on going up. We did a couple of tests to see how the solid reacts with acids. First up, 50% aqueous sulfuric acid. There's a yellow color due to sulfur being produced, and sulfur dioxide fumes are given off. Now 68% concentrated nitric acid. The reaction is a bit more vigorous as you'd expect given that nitric acid is an oxidizing agent and our product is a strong reducing agent. So the product is not compatible with acid solutions. But it is apparently stabilized in solution by a slightly alkaline pH, so that may be something to consider. Thanks for watching and stay tuned for more videos.